I'm going to share my experiences working on this domain-driven design, which is not a new design. It's been there for some time, and again, it's a buzzword, domain-driven design. There's a strategic portion tied to it, and also tactical how we are going to implement this one. So today, mostly I'm going to touch on the implementation, how we implemented, and what are some of the challenges that I have seen while implementing. And we'll talk about again, if time permits, we'll talk about more of like a patterns related to microservices, anything like an how orchestration pattern can be implemented within this context of domain-driven design, and also choreography pattern, how that can be implemented, and saga patterns. Just touch on those things. I want to touch on several things that will give us more high-level overview on these topics, and then later on in future sessions, if there is any particular topic that this group is interested in, then I'll be happy to talk about it. And also, I wanted to understand your experiences when you worked on these patterns, wherever you implemented. Please feel free to share that. But just wanted to understand domain-driven design. So how many of you worked on domain-driven design, have implemented this, or have understanding about domain-driven design? Okay. I see Anand. Yes, I know Anand has a lot of experience. Okay. Well, this is Ashan. Good. So I'm going to keep it again. Whoever has thumbs up, please chime in and then add more on top of what I'm trying to explain. But again, I'm going to stay pretty like a basic level in the domain-driven design, and then implementation, because we all are software engineers, and then how we solve problems is what I wanted to go into, mostly solving the problems and the different patterns that we can use. Okay. Let's talk about before talking about domain-driven design. First, we need to understand the concept of domain. We all use these. Hey, we are implementing domain-driven design. This is the domain. This is a financial domain. This is an insurance domain. This is say retail, healthcare. So, what is a domain? In a higher level context, when you are talking about domains, a domain is the focus area, or what type of service that company is providing. Okay. If you take FedEx, UPS, then what services are they providing? Shipping services, right? If you take Amazon, they have retail, online shopping, and they also have another domain, which is like more of cloud-based. And Uber, if you take Uber, then ride sharing, and there may be Uber Eats. So these are different business domains. What area are they focusing? What services are they providing? Okay. When you talk in that context, then this is a financial domain, this is an insurance domain, this is retail. But next, when you actually are trying to build a software, when you're trying to solve a problem, then comes a concept one level below, which is like a subdomain. Okay. What is this subdomain? Subdomain is it's a fine-grained activity. You can think of a fine-grained activity that aligns with your business domain. So what does it mean? Your business domain may be online shopping services that you are providing. But in order to provide that online shopping experience, there are certain things that you need to manage, which is you need to manage your customers, you need to manage your orders, you need to manage your products, shipping, delivery. So pretty much all these things are internally needed for your business to operate. Okay? So these are subdomains. If you talk in a domain-driven design model, these are your subdomains. But normally in an organization, when you're talking, you already know what your main domain is. When it comes to subdomains, the terminology is used interchangeably. Sometimes a subdomain is also referred as domain. So now what are these subdomains? How can we identify these subdomains? That's an important piece of this entire domain-driven design. So until now, say if there is a monolithic application where pretty much everything is part of one application, you have customers, you have orders, you have products, you have shipments, and you have pretty much everything that you need part of one application. And you may have one database or two databases that supports your application. So pretty much that's how a monolithic application is built. But when you're talking about domains, you need to think in terms of breaking it down into a logical sections. And how do you break it down? This is not based on any technology. It's not solely based on technology. Okay, it's not solely based on technology. It has to be based on your business goals, because your business goal has to align with how you are dividing your domains. If that is not done, then that means business is speaking one language, and then technology side engineers are speaking one language. Then there are more number of times where we build something that won't meet business expectations. So who is going to bridge the gap? In a DDD, domain-driven design terminology, these are called domain experts. Domain experts are your subject matter experts that come, and then they have a pretty solid understanding about the business and all the use cases. And you sit with them. This is like your strategic design, where you take your entire high-level domain and you break it down. That means, hey, I have an online shopping site. Okay, then your domain, what is your domain? Is it orders, products, customers, payment? So the next thing is, we're not going to go too deep into it, but even these subdomains have different categories. You can think of, there are some core domains. You call some of them as your core domains. What are core domains? That is what maps to your actual business core functionality. Okay, so a core domain is something that differentiates you with your competitors. Okay, so that's your core domain. So if there is a healthcare domain, then taking care of patients is your core domain activity, because that's what differentiates you with other businesses. Then there is another concept of supporting domains. So what is supporting domain? Supporting domains are something that will support your core domain activity. It can be a billing system, or any accounts receivables, accounts payable type of a system, which is out of the box available for you, where instead of you building something, you can go and buy that and integrate with this. Because your core is what? Your core is, if for a healthcare system, it's taking care of patients. Okay. And then there are some general domains which is more of authentication, authorization. These are the things that are already solved by someone, and then you wanted to just use it. So these are the different concepts. If you have not used domain-driven design, I would recommend, there are two books. One is Eric Evans' Domain-Driven Design. That's one book that has lots of good use cases, a pretty detailed domain-driven design. And then also there is one more book. It's written by Vlad Kononov. I can put that on the chat. Vlad Kononov. I don't know if I'm pronouncing the name right, but that's more of, it's called a monkey book. There's a monkey on top of that book. It is a domain-driven design. If you search for it, you're going to find it. So that gives you more strategic type of breaking it down, the domains. Okay. We'll, again, as I said, we'll talk more in implementation standpoint. But before we go to the next topic, any questions from anyone? I see a couple of other people joining also. Just any questions? Okay, great. If you have questions, feel free to ask, because this, I want to keep it pretty like collaborative session. This is not like I'm sharing my experiences, and equally I want to hear from you. So now let's move on. I'll spend a few minutes on this designing your domains, identifying the domains, and bounded contexts. Okay. So how do you identify your domains? There's a concept when you identify it just within software engineers sitting and then trying to reverse engineer and look at the existing system, or try to understand based on what you read and some analyst explaining you, and then you come up with those domains. Most of the times, then there'll be confusion. The language that we are speaking and the language that the business expects us to speak, completely different. So the DDD has a concept of ubiquitous language. Ubiquitous language is a common vocabulary that you need to agree on. So for example, there is something, if you say customer, then the customer definition is different in different contexts, but you need to agree what is the definition of that customer within one context. And that is called a bounded context, or a logical boundary. Okay. So if you take one domain, if I take a customer domain, so my customer object or my reference to a customer has to be consistent within a scope of something. So what is that something? That is the logical boundary. So when you are building something, your monolithical applications have everything is in one big box. That means you have all your modules sitting in one application where you build it, you scale it, and you deploy it. So everything is in one. So there are some use cases where monolith is the right choice for such kind of applications. But if you are building distributed applications, you need to think more in terms of what are my domains, business domains, and how I identify this logical boundary, because I don't want to put anything that I don't own. Think about it in a way that if you are taking an ownership, then you only build something, or you only define that this is my boundary. I will make sure that I'll give you everything that is needed from this area. Say if you take customer, there are distributed teams, one team working on customer, one team working on orders, one team working on payments. Okay, so everything related to customer, that means I wanted to manage customers, I wanted to add customers, I wanted to save customer preferences. Okay, if there's an online shopping site, when somebody is visiting, I definitely want to capture the customer information. On top of that, I also want to save the preferences, what type of products that he or she is ordering. And should I keep track of those products so that whenever something new comes in that category, I wanted to notify them saying that, hey, we have a new product that we added to our list if you are interested. Okay, and then I wanted to also store communication preferences of this customer. So communication preferences, whether they wanted an email to be sent, whether they wanted a text message to be sent, or a paper mail to be sent, whatever. So anything that you feel is related to the customer stays within the boundary of that customer domain. But anything that is outside the customer, so for example, a customer is placing an order. Okay, yes, customer is placing an order, or he's trying to buy a laptop. Okay, so that's an order that he's placing. Then is that something that should stay in the boundary of the customer? So that's a question that you need to say, because this is more of related to order, because whoever is managing the orders, they should know the context better, bounded context, where the order has to be part of that order subdomain or order domain. But think about it. If you have customer and if you have an order, there is something that has to map these two different domains, because by itself an order domain cannot live. I mean, it will live, but who is placing an order? A customer is placing an order, and a customer is placing an order for a product. That means there is a dependency. So it is very important as part of this domain-driven design to understand the context mapping, how these bounded contexts are mapped and how these domains are talking to each other. So all these things are very important, and it takes a lot of time for you to understand. It is not like you take your existing system and just immediately draw that these are my domains, this is how they are related. So it takes good amount of time, and you have to apply some principles and sit with your domain experts and build. But basically, your bounded context is a logical boundary around your domain so that you don't put anything that your domain doesn't own. Okay. So if there is anything that you put that your domain doesn't own, then immediately you will hear some people saying domain contamination. So that means, hey, this is not supposed to be here. So, but at times what happens is engineers, when they are building, they will put certain things that are not related, and then slowly these things have to be moved. This is like a progressively elaborating our architecture based on some experiences. Okay. Now the same context will look at microservices also. Think of when you are visually, I'm sure many of you worked on microservices architecture. So when I talk to some people, they have done microservices, but their definition of microservices can be different. So initially, this is long time back, understanding of microservices is, hey, I wrote a service that returns claim information. That is a microservice. Okay, claim information. I return subscriber information. So that is how initially some people I heard the definition. But if you think of a microservice is more of like an independently deployable unit that can be scaled independently. And within the microservice also, you need to think of a bounded context, boundaries of your service, which is a local boundary where when I create a microservice, I don't want to put a whole lot of things in microservice. There's a single responsibility that I need to think of. What is the purpose of my microservice? If I add more things in my microservice, then what is the difference between a monolith and microservice again? Right? Your microservice, if you add more
Enterprise
functionality,
architecture మీద
you're uh, you're uh, you're adding more
yes,
functionality
ఈరోజు ఏదో
there.
లైవ్
Hey, I think Ram, can you mute yourself, please, if you're not talking? Thank you. So this concept of microservice, there is a bounded context there also. So you don't want to add anything where you are creating a hard coupling between these services. So if you take a customer and payment, I'm just saying a customer and payment together, and you create, I've seen there are applications where customer and payment are in one microservice. But what you're doing is the moment you put customer and payment together, then you are creating hard coupling where your customer information, your customer microservice may take care of registering a customer, their email, their address, their phone, their preferences, their communication preferences, all those things. At the same time, you also have a payment related service. So what if your payment service is down? Okay, so you need to think about that. You don't want your entire service to be impacted. So that's the reason you need to think of what are my microservice boundaries. When I'm creating a microservice, I need to visualize in a way that I wanted to have this microservice with single responsibility, where if there is anything that I feel has to be independently deployed, then I'm going to keep it as part of another microservice. But the question is, are these microservices part of one domain or a different domain? This is like a bottom-up type of thinking where you need to think, okay, if these are my microservice, do they fall in one domain or payment is completely a different domain? So once you put that in a different domain, what type of information is needed? Okay, that payment may need a customer information also. Then what's the point when I have customer information sitting here? And then do I need to completely replicate that customer information there? Do I need to duplicate the data? No, but you need to have some kind of data that links a customer to the payment. Okay. So all these concepts are internally, this is like a tactical designing of your domain-driven model. You need to think about all these. What are my domains, subdomains? What are my entities, value objects? What is the bounded context? How this context is mapped? And then how can I visualize these boundaries and whether one microservice, whether multiple microservices, and where these microservices fall? Okay. This will lead to our next topic, which is more of like, I know because you mentioned about whether a microservice needs one database or what is the philosophy against one database for a microservice versus are there any other options? So we'll talk about that, and then I'm going to touch some implementation concepts like a choreography or some kind of a orchestration pattern. Any questions so far?
Yes, this is Santosh. So, do you think that for the transactional data, let's suppose when we think about master data, let's say as an example, you said about the customer. So, thinking of a particular database, we can visualize these things like all the master data, we can have a separate services. But what about the transactional data? At that time, you need a relation between two entities, as you said, that payment and a customer. Both have a relation, like one customer is going to do a payment for a vendor. So here, three things are combined for an order and a customer and a vendor. So now, where we are going to place this transactional data? So that time the confusion comes.
Yep. Santosh, that's a good question, and that's a problem that again has to be solved as part of microservices. And the when we are talking about transactional data, uh, let me explain this question one time, and then we'll talk about options here. So we have customer, we have product, you have an order. So if you have customers, product, and order, these three, if you are calling them as three different domains, and if you are building microservices within these domains, and if you have databases, say one database for each of the microservice, you are storing customer information here, you're storing product information here, order information, that's transactional data, where your order cannot live by itself. Your order needs some kind of a mapping or a link to the customer and product. So when there is this kind of a relation, where to store this data? Should we store in one place? And if we store in one place, what are we gaining here? Because again, this is a complete we are coupling these three domains together. Then what alternatives we have and how we need to implement that is what I'm going to talk. Santosh, did I capture your question right?
Yes, yes.
Okay. So let me give some context here. See, when we think about domains, when we think about domain-driven microservices, implementing this microservices architecture, we need to visualize in a way that everything is like a resource and everything is independently deployed. So that means if something is down, maybe 80 to 90% of what your domain owns, or your microservice functionality that you are offering, should still work. Should not see, if we take a monolith type of an application, if something is not working, if your payment is not working, the whole application will stop working, because everything is so tightly connected. But if you have a customer type of domain and a microservice that you create, so if there is a screen or UI that you build, an application that registers customer can log in, customer is authenticated, authorized, and then you see your profile information, you see all the emails that you have, and all the products that are offered by that company for you to buy all these things. But if order service for some reason is down, then only thing is you may not place an order. At times it happens where a one functionality is not available for you, but at least other functionality, I can still access my information. I can do certain things. I can add my payment. But if order, even if it is your core feature that you're offering, if that is not available, it's not that your entire application is down. Okay, that's the philosophy behind managing these things. But where do you store the transactional data? Normally, in a monolith, when you store a transactional system, if you say a relational database, you will create a customer table, you will create an order table, you will create a product table, where your order will have a referential key mapped to customer. Your order will have a referential key mapped to your product tables. That means your entities are created in a way that your order is internally references using a foreign key relationship to your customer and also your product. Everything is in one database, your data is stored, and you join the tables and get that. But in order to decouple these applications, you need to have order information sitting in one database. Your customers' information will be sitting in one database. Product will be sitting in one database. There won't be any hard reference key tied to it, but there will be some kind of a mapping key stored in each of these tables, and via APIs, you are going to reference these things. So whether you go synchronous or whether you go asynchronous, it depends on your needs and the business. So if it is synchronous, then you make a call, you get the customer information, and then you know the customer ID, you make a call, and you get all the orders that the customer has placed, you aggregate that information, and then you send it to the client. And when you're placing an order on the screen, you have the customer information. So you get the customer key tied to it, the primary key tied to it, an ID tied to it. And then you know the product that they picked. If it is like a MacBook that they picked, you know the product ID. Now you make calls to two different domains and get that information and aggregate that information and return that, make a call to the orders domain. But you are not storing duplicate data, but you are only storing the reference to that master record. So customer domain or customer database within that, they'll have the master information about the customer only. I don't need any other information. I only manage customers, so I should only have customer information. Products, whoever is managing products, their transactional database will only have product information. They don't care about anything else. And orders, they need order information, but they need also a customer ID and they need product ID. But they don't need, hey, the customer ID's first name, this customer's first name is John and last name is Smith. Okay, fine. They don't store that information locally anywhere in the domain. They always go to the domain that owns the data, which is customer, saying that, hey, I got a request. Can you tell me what is the customer information for this ID 100? Then I own customer, so I give the data back saying that, hey, his name is John Smith. Okay. Okay, if tomorrow, if there is a typo and if something changes, then it is only changed in one place, not in all the domains. We are not duplicating. But with this model, you will hear in some places that there is some data duplication that may have to happen depending on the convenience and what you're doing. But those are the use cases that you need to talk. But Santosh, to your question, the transaction, it's not that master data is stored in one place and transactions. So everything is within the boundary of that domain. Whatever that domain owns is stored in that database. And then some kind of aggregator pulls the data and returns the data back. That is one pattern. And then there is also another pattern that we are going to talk. Did I answer, Santosh, your question, or you?
Yes, but again, one question arises from
Yeah.
your solution. Sometimes when we talk about like getting a data in a single call, let's suppose, as you have given example, that we have all the tables in the relational database, and we can put a join in between all these three entities, and we can get the data in a single shot, a single view. Now, if we are having a different database with different domains, I mean, separate domains, then what will happen? Like, first of all, we will get the order of something, and then from there we have the ID of the order of the the customer. Then again, we are going to hit the database or the API to get the other information. So it will be like consecutively three calls to show all the information in a single page. So here, sometime the question comes like you are increasing the wait time to fetch a single information. You are hitting the database. I mean, going to the wire three times. In that's why whenever we think about this, then some at some point of time we again think that whether it is a right way or we can have a single database where we can put all the three information. I mean, transitional information in a single point where we can put a join and we will get the all information in a single. So here how you, I mean, convince like this is a right way that we can have a small domains and API expose, and we can make a three call and we will segregate all the information on the application and then we can show it. So here sometime the problem is like we need a justification to tell the customer or anyone, I mean, the development platform that yes, this is the best approach. So I mean to say, my question is how we can justify that this is the right way.
Yep, absolutely. Again, this is also any company when they start taking a monolith and converting it into more of like a microservices architecture using domain-driven design or simple microservices when you're creating. These are the common questions. These are not like some kind of an edge cases. These are common questions that arise on day one of your workshops, right? Hey, how is it performance wise? It'll be easy
Yes,
for
yes.
me to say select from customer, join product and orders on customer ID and product ID, and then I'm going to get everything, and I'll add solid good indexes on these tables so that my execution plan is super fast and it will return in no time. And there is no complexity here. So what is the point? Why do I need to put these three things in three different? See, there are applications where that model may be right. It all depends on how big your application is and how your application is integrating with other applications. So first thing is you need to think more in terms of like a distributed architecture where you don't want to create any single point failure where you put all these things in one table. It is convenient, no doubt about it. But your order information, customer information, when everything is in one and your database is down, then pretty much you're bringing your entire system down. So this is more of trying to identify same thing, the logical groupings, logical boundaries, so that you take these things and you group them. But now question is, how is it going to perform? Like if I have to make three calls, now I'm making one database call. Instead of that, I'm making three database calls. Fine. So these are the pros and cons that you need to think when you are converting any of your applications into this microservices. Again, microservices, the concept, it is going to be, it it will give a lot of advantages in terms of you can independently scale based on the load, independently deploy, but cost wise, it is going to be a little higher end, because here you are spinning multiple containers, multiple applications to scale, and at the same time, database, which we are going to talk shortly about the database. So, so all these things come into picture. Yeah, all these kind of things come into picture. But if your application is integrating with multiple areas, because my customer is needed by three different applications. Say if you take uh, the customer information is needed for online shopping, my product information is needed by a couple of other applications where they take this customer information and do something. They will send marketing materials, they'll send some ads, campaigns to these customers. Same thing, my product information is needed by some other system that checks on how many products do we have, what kind of products people are ordering, and do some kind of analysis on that one. So there are other teams, other applications that have their own pipeline of things that they wanted to do. The moment when I put everything in one place, I am introducing a single point of failure. And if that happens, then pretty much four other teams are sitting idle saying that I'm not able to access this database. But if you put right things and define that, yes, there is some overhead tied to it, but if you can manage it right, you build your APIs, you put proper process monitoring system, and you make sure that your APIs are returning data. There's no latency. Everything internally, if it is written properly, then the aggregation is like super fast. It is not going to take time. But again, you have to, it depends on the use cases, what pattern or a design that you choose. Yes, Anand?
Thank you. Correct.
Yeah. Thanks, Suresh. I just want to augment what you just said, because I think what folks would be interested in knowing is that a domain-driven architecture is not a data architecture. I mean, it's not only a data architecture, it is also an entire enterprise architecture. So so this also involves technical architecture, your cloud architecture, it involves web application architecture. They all have to come together. So in that use case which Santosh you said, we could have, for example, we can have a caching, right? If there are things which are more commonly accessed every time, if this application which is trying to use these microservices are commonly just going after orders and payment, you can have some sort of a caching mechanism where those things are displayed faster to the end user. So this is just an example, but a domain-driven architecture is actually an enterprise level pattern, and not necessarily only a data pattern. So I hope I'm sorry. I just want to just augment what you just said.
No, absolutely, Anand. Thanks for adding that. Yes, yeah, this is more of holistic and enterprise-wide. This is not data, but data is one of the problems that we need to think about also. But this is more of how what you're coding or what you're trying to come up with, how it aligns with business, and how your business wants to function. If your business comes to you and says that, you know what, either I want everything to be available, and if something is not, it is okay if everything is down. So I mean, this is like if your business model says that I want everything all the time, otherwise it is not going to help me, then you are going to keep that in one context, and then you'll say, okay, I will have one database, multiple tables stored and the relations, and then if that is down, everything will be down, which is expected. So it all depends on your business use cases. Yes, Vikas?
I want to add one more point to your argument, to Suresh's argument, that personally we have seen, like in enterprise. Let me take example of customer data. So you will have multiple systems and that customer data is copied everywhere. And then you see that there's a synchronization issue. Customer data was updated in one database, it was not updated other databases, and all kind of inconsistencies come. And in domain-driven design, I have seen that advantage. Okay, customer, you go to the customer database, customer domain, get the data. It is the way it is. That means it's there's no, you don't have to worry about data inconsistency. That's another very big plus point in my mind. Over to you,
Yep.
Suresh.
Sure. Thanks, Vikas. Again, I know we have about 14 more minutes, guys. I want to keep a couple of, I know we are talking and everybody is asking questions at the same time. So, and also we'll keep about 2 to 3 minutes at the end for other questions. But let me talk about one important thing. Your microservices definition says that every microservice should have its own database. Why? A microservice must be independently deployed. And when it is independently deployed, independently maintained, having an independent database is going to help, right? So having an independent database is going to help. And this independent database, when you have that, then it will give you the entire control on that one. But is it logical? The question is it logical to have an independent database? Think about it. If you go granular, if you have a customer domain and if you create 2-3 microservices, okay, and when you create 2-3 databases, earlier your DBA team has only one. 1 second, if you can hold on, please. Sorry about that. So if you have only one database, then there is a dev, QA, staging, demo, production, about 4 or 5 environments. And your DBAs are used to managing 5 databases, database refreshes, database replications, and all those things, right? So when you have one database for each microservice, and if you create 2 microservices in your domain, in your customer domain, and 2 in orders domain, 2 in products domain, then there are total 6. Then that means 6 databases in each environment. And if you have 5 environments, then there are 30 databases. Cost-wise, it is going to be on a higher side. Maintaining, refreshing, replicating, and if it is like a cross-region kind of availability that you want to have, east-west, you need to have in the east zone and west zone, then definitely cost is going to go high. So question is that what normally organizations do? Yes and no. This is where it is a topic to debate. So what I have seen is, if you have a one microservice that handles most of the customer related related functionality, then you create one database, then fine, you will have one database for customer. The moment when you are adding more and more microservices, because I have seen organizations where there are about 70-80 microservices. When you have 70-80 microservices within about 5-6 domains, then what happens is you will have 70 databases in each of the environments. So I have seen a couple of options that I wanted to share. By no means, some people may say, microservices purists may say, no, that that deviates from the best practices. Absolutely, I'm not saying that. Hey, it is okay to do that. But in what context it is okay to do that is what I'm going to explain. See, I have seen some places where you have one database for each domain. That means your customer domain, even if you have 2 to 3 microservices internally, will have one domain, one database. And then you can maybe have some logical separation by creating schemas within your database if needed. But otherwise, there is one database. Then what you're saying is, if my database is down, my 2 or 3 microservices that have pretty much all of them cannot operate. If you are okay with that expectation, if your business model is okay running that way, then you can create one database for each domain and then have schemas where you will have logical segregation. That means instead of 3 or 4, you will have one database. But tomorrow, if you are adding a new microservice in your domain, and if your new microservice needs a separate database, that is possible. You create a separate database for that particular microservice because you want that to be independently available regardless of other. But rest of the microservices, if they are okay to operate as one unit, first thing is, as part of your analysis, you should question, is this one microservice candidate? Why are we breaking this into 2 or 3 microservices? If you have a valid answer for that, yes, go for it. But otherwise, when there is only one database, can we have this functionality grouped as part of one microservice and make it available? Okay, so that is something that you need to think about. So a domain can have one database and you can use schema level segregation if needed, but that depends. You need to talk about that use case. That way you're not having hundreds of databases to maintain and manage. So you can have, if you have 5 or 6 domains within your business domain, then you can have 5, 6 databases, and anything that needs a separate database, you can always create and use it. So that's what I have seen and I have done. I want to hear from this group if you have seen anything similar to that, or if that causes any problem based on your understanding of microservices.
Suresh, like personally, I have seen people applying microservices only on the middle tier, where database is monolith, front end is monolith. So that's what I have seen. Databases people are, that's what there's a lot of stuff happens to create independent databases, how to keep in sync, all those things, all those issues arise. So those are my experiences.
Yep. Again, there is it all depends on how granular your microservices are. If your microservices are granular, then if you start creating the databases, at some point your infrastructure team is going to say, what's going on? My cost is going high. And on top of that, you're coming back and saying that, hey, just in case if east zone on cloud is down, I want all the traffic to route to west zone. So I need to have these things available in west also. Then that doubles my cost. So earlier I used to have one instance of Postgres or MySQL database running. Now you're asking me for 40 Postgres databases. Then if I create these many databases, who's going to manage it? Okay, all these things, everything depends on your business, how your business wants to operate. And then again, it can be anything, guys. I'm sure if you speak about agile framework, then you need to see what works for your company based on your maturity and make certain decisions. In the same way, don't deviate from the core principles, but see what makes sense based on your context, and then make decisions.
Suresh, Asan, who's enterprise architect at Moderna, he has some input. Go ahead, Asan.
Yes, please.
Sure. I'll try to be quick. I know we don't have a lot of time. It's like, so basically, coming from my past background, coming from the enterprise service by design, service-oriented architecture, then microservices, there are a lot of similarities, but there are also at the same time, there's one evolved from the other to a certain degree, in my opinion, but also at the same time, there are a lot of patterns kind of coexist. You have to kind of not just say, okay, this is the hard and fast rule. This is the only way I'm going to implement certain things. I'll give an example in a regulated industry like a pharmaceutical world. How data moves oftentimes could be a big roadblock. How long it takes you to go out to the market to release a product, release a technology product. Because what is the concept called GXP? That means if data moves if you have multiple databases, if you move, that means you have to verify every data, and their QA process is extremely strict. That could take months, literally, to kind of just to release a product. So oftentimes, sometimes, as you were saying, Suresh, sometimes, yeah, there might be a case for having a database for a microservice, but there are other cases that sometimes it's just a standalone service. Build with the service-oriented foundation is that you provide the data and it computes and provides you a result. So in that case, a database may not be necessary. So it's like kind of depends on the design and what problems you're trying to solve in some of these, and how it ties with the business process overall to a certain degree. I've seen that, and sometimes it's just you have to use complementary patterns to kind of have a successful microservices strategy.
Yep, totally agree, Arshad. Yes. Yeah, it depends on your business case, and then at times you have to make decisions based on that. And yep, completely agree.
Yeah.
Yes, Anand?
Yeah, it's the same thing. I think Hassan, I think your name is. I think you said it very well. So the decisions, in my opinion, also should be governed by what kind of business capability and what kind of technical capability we're trying to provide, right? Including security. Like, for example, right, there could be data which is in the same domain, but the data which is handled by microservices could be PII, something is more protected. Maybe you create a separate database for that. So there are those kinds of decisions need to be made based on how you're using the data. So there's this business capability usage of the data also could drive whether you want to go down to have each, which microservices you can have a separate database, which one you should not, kind of thing.
Yep, absolutely, Anand. That's my, as I said, if there is any one use case where you feel that this data has to be managed in a different way, cannot commingle with the rest of the customer same domain data, and that application that is going to use this data has to be available all the time, regardless of whether other portions of this domain, the functionality is available or not, then you immediately pull that and create your own database for that. Okay. So I know we have two minutes, guys. I also wanted to talk about choreography, orchestration, and saga patterns, because that's more of like a tactical implementation of it. But now I see what Vikas was saying about initially when I said, hey, Vikas, how about talking about these things? Then I said, over ambitious goal, which is, I don't know, in an hour you'll have time to cover, but definitely, if this group is interested, I'll be happy to talk about one practical use case where how this domain-driven design can be implemented in terms of orchestration pattern, using choreography pattern, what are the pros, what are the cons, how to compensate if there is any failure, and where to handle the exceptions, more real scenarios than what we see in the books, because I have encountered some of those things, and I'm sure you have seen those scenarios. We can share our experiences and learn from each other.
Thank you, Suresh. Anybody has any question before we wrap up?
Yeah, Vikas had one more quick thing. As a future session, one other thing, Suresh, you can also handle, which I'm encountering in my new workplace, is about whether domain-driven architecture is useful for real-time or gaming kind of a situation. That's a really unique problem somebody has posed to me. It'll be nice if you can, in a future session, do that. So rather than having a transactional system, which is what you explained right now, But if you have a streaming system, if you have some sort of a gaming kind of a thing, how is domain-driven architecture? How does this solve that problem?
I have additional request, Suresh, like is domain-driven design is appropriate for reporting kind of applications? So that's another thing you can add to your agenda.
Yeah, again, we can talk. I mean, we can
Sure.
see reporting as a separate domain, or can we break it down? We can always. That can be a good conversation. Yeah.
So thank you very much, Suresh. Like when I started this channel, one of my vision was like I'll incorporate world. There is a lot of talent, and a lot of people. They were great managers, technical leaders, enterprise architects, and they never published anything. And I was hoping through my channel I'll bring that talent out. So thank you very much, Suresh, for accepting our request. I hope we see you more, and also other architects. Also, I have some other enterprise architects, and if you have some thought, you want to give some presentation, uh, we look forward to hear from you. So thank you very much, Suresh.
Great, Vikas. Again, thank you for inviting me. And again, guys, this is a forum for us to learn from each other. And I'm glad, Vikas, your channel has a lot of good information, and this allows us to just maybe once in a month or whatever the time frame is, can talk and share our experiences, and see if there is any problem that is already solved that we can utilize this, similar patterns. Okay. Good.
Thank you.
Thank you, everyone, and have a good evening. And you are in India. Have a good day.
Thank you,
very much,
Vikas, for
Suresh.
arranging
Thank
this.
you.
Thanks,
Thank you.
Vikas.
Good night, guys.
Night.